Hello, welcome to Dubeke Consult, and today we'll be looking at how we can detail our slabs. When we speak about slab detailing, all we are trying to do is represent the reinforcements and concrete that will be used in construction of these slabs by lines and call out. If we have a given floor plan, these lines that represent our reinforcement should be able to clearly specify the span at which this reinforcement will run, while the callout should be able to specify the total numbers of this reinforcement required for construction, the diameter of the reinforcement, the bar mark and spacing, and also specify if this reinforcement is a top or bottom bar. To achieve a comprehensive slab detailing, there are certain rules that needs to be followed which are in accordance with your design code. We'll be getting ourselves exposed to some of these rules today. If you find this video helpful at any point, do not forget to like it, subscribe to the channel and turn on the notification bell so you get notified anytime we post new videos on our channel. Without wasting much time, let's jump right into what we have for the day. Hello, welcome back to Dubeke Consult, and today we'll be looking at how we can detail our slabs. As we've earlier said, the idea for detailing our slabs is to represent the reinforcements that will be used in constructions by lines and call out. So we have over here a floor plan that has been given for detailing. This is our floor plan consisting of our beam structural layout that is supporting these slabs and our slabs layout. We also have here the instruction for detailing, and from the instruction for detailing we've been asked to provide Y12 running at 200mm center to center spacing for the bottom bar, while our top reinforcement we are to provide Y12 also running at 200mm center to center spacing. Then the concrete cover for the slab, both from the top, from the bottom and the sideways, is given here as 25mm. So with this instruction, let's see how we can detail these slabs effectively. So to begin our detailing, I will create a copy of this provided floor plan. I'll select and copy this to somewhere here. And as you can see, we have our indications of the type of slabs here. So by this indication, you agree with me that this slab should be detailed as a one-way slab, while this other slab should be detailed as a two-way slab. So permit me to take out this beam text so we can only see the properties of our slab on this layout. So I will select this, and this is under the text layer. So I will select all of this, then I'll come to quick select, come to layer, and I will come here to text. Okay, then I can erase. So now we have just the properties of our slabs, and like we earlier said, this slab will be detailed as a one-way slab by this indication, while this should be detailed as a two-way slab, same as this. And the overall thicknesses of our slabs are is 150mm. So we get to see how we can detail a one-way slab, and we also get to see how we can detail a two-way slab. Then, as we know, our one-way slab and our two-way slab, we can easily get this by dividing the longer span by the shorter span. So if it gets more than 2, then that is considered a one-way slab, while if it's less than 2, it is considered as a two-way slab. Our one-way slab, it is expected that we run our main reinforcements at the shorter span, while for our two-way slab we will have the main reinforcement running both at the shorter span and also at the longer span. So let's establish a few facts or few ideas that will help us to detail these slabs effectively. So the first fact I would like us to establish is we will be having the main bar, and we'll also be having the distribution bar. All depends on the type of slab we are detailing at that very point in time. So we have the main bar and we have the distribution bar. So then I would also like to establish another fact. Okay, permit me to delete the slab thickness call out. Then I would like to cut a section through this point. Okay, let's just have a quick section through this point. If we draw a section here and we are looking at this slab, if we cut through this slab and we are looking at it from this part, we should have something like, let's divide this screen. We should have something that looks like this. Okay, so at this end we should be having a beam, which is this. Then after the beam we have just our slabs, which is this part, and beyond our slabs we have another beam, another slab, another beam, then add a cantilevered part of the slab. So beyond this beam we should have beyond this slab we should have beam, slab, and also this cantilevered part. And if you are familiar with structural arrangements like this, you should understand that we will have a moment diagram that looks just like this. So at the span zone we should be having our sagging moment, while at this support zone we should be having our hugging moment. So this will take us back to our basics, which requires us providing top reinforcements at the maximum somewhere around here, then the bottom reinforcements at the maximum somewhere around this area. Okay, so these are just the basics that will help us to detail, and let's establish this fact as well. So we'll also get to understand that we will be having a bottom bar, and we also have a top bar. Okay, so this is another fact that will help us to detail that we've established. Now the next important thing I would like us to take note of is, considering this two-way slab, let's assume we want to detail these two-way slabs. Okay, so we'll be having our reinforcements running, our main reinforcements running both at the shorter span and also at the longer span. But these reinforcements will not be welded together at the same plane. Okay, they will not be at the same plane. One of these reinforcements has to be placed upon the other, and the one running on the longer axis or the longer span has to be placed on the one running on this shorter span, in order to enhance the rigidity of the slabs. This is just few principles that we have to establish. So this one will serve as the reinforcement running directly on this other reinforcement that is running at the shorter span. So they are both bottom bars, but one will be placed on top the other. So that's to say, at the bottom zone, okay, we should have indications of another layer of reinforcement, which will be our bottom one reinforcement. Okay, then we should also have another layer of reinforcement, which should be our bottom two. We can also refer to the bottom one, which is the one running at the shorter span. We can also refer to this as our bottom reinforcement. Then this can be referred to as our bottom top reinforcement. All right, so this is another fact that we will be implementing in our detailing, and also this applies towards our top bars. Okay, so we also have our top bars that will run on the first layer, and the top bar that will run on the second layer. So this can also be denoted by our top, bottom, and what our top layer of what reinforcement. So with this few facts that we established, let's go ahead and what begin the representation of our reinforcement with lines. So I will delete all of this, and we can always make reference to this if there is any need to, but I will take out all these slab annotations. So we'll detail or we'll draw our reinforcement in easy steps. First, we'll start with what the bottom bars on both the X and the Y direction before we can move on to our top bars. But there are chances during the course of representing this reinforcement we might also get to draw both the bottom bar and the top bars together. Okay, and we'll begin this by creating layers for each of these reinforcements. So we'll come to home, and you can come to your layer properties, and what we create a new layer for what the bottom reinforcement. So you click on here to create a new layer, and we'll call this, let's say, bottom reinforcement. But I already have a layer for this, so you can go ahead and create yours, but I already have a layer in my template for my bottom reinforcement. So I will just close this, come over here, then I will come to my bottom rebar. So this is the layer for my bottom rebar. Okay, then I also have a layer created for my top reinforcement. So if I come here and I come to top, I have a layer for my top rebars. Okay, so I have separated these properties of the different layers. I have decided to use a broken lines for my top bars, while my bottom bars we also have what a straight and continuous line. So this is just to differentiate, so when the artisans on site get to see these lines, they understand that our continuous line is what the bottom bar, while these broken lines are our top bars. So you can go ahead and create your own layers as you desire, and I will take this back towards my bottom bar layer. Then now we can begin drawing our reinforcement. Now to detail our panels, there are two ways we can run our reinforcement, or there are two basic ways we can choose to detail our slabs. We can either detail per panels, or we can detail by the length of your reinforcement. So if you are detailing per panel, we will run our reinforcements as though they run from each of the panels of this beam and they terminate at another beam. Okay, so this is the first method of which we can detail our slabs. Then the second method is to consider the total length of your reinforcement, which is mostly 12 meters, and you can run your reinforcements across these beam sections, and you terminate it when you are exhausting the total length of what your reinforcements. Okay, so for this very class we'll be detailing per panels, and in subsequent class we'll see how we can detail per length of what your reinforcements. Okay, so we'll start from this very slab over here, and we'll draw our reinforcement from what this beam up to what this beam. Now let's consider the end conditions of this very panel. So if you look at the topmost part of this reinforcement, you will agree with me that our slabs terminate at the end of this beam. Okay, so this beam is what the final end of our slabs. So here we can have what we call a restrained end. If we go to the clockwise direction at the staircase as well, this is also what a restrained end, because we do not have what any slab coming at what this part. All right, then if you still go to the clockwise direction, if you look at this part, you will agree with me that we have what a slab just beyond this beam. Okay, we still have what a slab beyond this beam. So this is what a continuous edge. All right, this is actually what will be considered as a continuous edge of the slab. Same with the left hand side, we also have a beam here, but beyond this beam we have another section of what, our slab. So this will be considered what, as a continuous edge. So the properties of this very panel, we have what, restraint end at the top, and we have what, a restraint end at what, the right hand side, while we have what, a continuous slab both on the left hand side and also at the bottom zone. Okay, so each of these conditions, there are principles that helps you to how you can detail your reinforcement. So we'll start with what, the restraint end. It is expected that you always terminate your reinforcement at your restraint end, and not just that, this reinforcement that is coming from the bottom zone, we have to return into this part of the slab by some percentage, and that is given by 25% of this total length. Okay, 25% of this total length, or 50 multiplied by the diameter of what, the reinforcement. So whichever is greater between 50 multiplied by the diameter of your reinforcement, or 25% of this span, is what you take at what, your return length. So in essence, have this section like this. Okay, and let's say we are drawing the reinforcement from this part to this beam, and we have this restraint end here. Okay, we are expected to return this reinforcement back into this slab either by 25% of this span, okay, or by 50 multiplied by the diameter of this reinforcement. Okay, whichever is greater is what we should be going with. So for this case, let's come back to here. So for this case, we have to return this reinforcement as a top bar, and if you dimension this from here to here, we'll have a what, length of what, 3000 millimeters. Okay, which is what, 3 meters. Then if we multiply, if we come to our quick calc and we'll multiply 3000 by 25%, which is 0.25, we should be having a distance of what, 750 millimeter. Then also our rebar size is what, 12 millimeter. So if we multiply 12 times 50, which is our 50D, we have what, a length of what, 600 millimeter. So whichever is greater between 750 millimeter or 600 millimeter is what we will use at what, our return length, which will serve as our top bar. Okay, so we'll adopt a return length of 750 millimeter for this reinforcement, and while you are drawing this, representing this reinforcement, you should understand that this rebar cannot get to the end of your beams. Okay, this will not get to the end of your beam because there is a provision for the concrete cover of your slabs. The concrete cover of our slab has been given to us as 25 millimeters. Okay, so in essence, this is going to run and stop at 25 millimeter just before the end of our beam. So we'll offset a distance of 25 millimeters up to this part, and we can now have what, our reinforcement terminating at this point. So for this to return as a top bar into this panel, right, there has to be a what, bent up length here. There has to be a bent up length. So let's take an illustration here. So this is our slab of 150 mm thickness, and over here we have what, our beam. So for the fact that we are at a restrained end, if we want to get this bent up length that will come from the bottom bar and will return as a top bar, if we intend to get this length, all we need to do is subtract our concrete cover from the top and subtract the concrete cover from the bottom. Then the reinforcement will run directly on this concrete cover, then it will return between this space. Okay, So if we offset a distance of 25 from the bottom and also from the top, okay, we are left with our bent top dimension as what, 100 millimeters. Okay, so this reinforcement is expected to run from here and stop at 25 millimeter at the end of our beam. So it will run from here to this part, then it will come up to 100 millimeter before it returns back in towards our slab. All right, so with this understanding, we'll come back here, and from the line of this 25 millimeter we'll draw a line of 100. Okay, then we'll draw a line to the end of our beams. Then from the end of our beams, we can now push our return length as calculated by 25% of this span of 750 millimeters. Okay, so from here to this part is what, our return length of 750 millimeter. So this is how you represent your reinforcement at a restrained end. Now, do not forget that the top bar you've provided here can also be called out separately. Okay, the top bar that is returning into your slab, you can also have them in this manner. Okay, so it's not a must that you have to combine two of these reinforcements together. You can choose to detail this what separately, because this is a bottom bar while this is what your return or the top bar. But for simplicity and for us not to have a lot of lines on this detailing, I would prefer we join both lines together, then we'll separate them by what, their line types. Okay, so I will come here and match this. Let me match these properties to this. Okay, so we have our broken line representing our top reinforcement. So now we are done with the restrained end, and let's move on to the other end of this reinforcement. So at this other end we have what, a continuous slab, and due to this fact of having a continuous slab, we don't necessarily need to return this reinforcement 25 millimeter into this beam. Okay, as a matter of fact, we can choose to increase the length of this reinforcement by, let's say, a minimum of 150 millimeter, and this is not necessarily to counter moments at this point, but to enhance the connectivity between our slab reinforcement and what, our beam reinforcement, because our reinforcement is a ductile material. So if during casting process, while they are stepping on this reinforcement, this length can choose to what, retract. Okay, you can choose to retract out of this beam while they are stepping on it if it is not properly bonded. So it is always advisable during construction, you can extend this to about a minimum of 150 millimeter, but we'll leave this detailing at the end of this beam. Okay, making regard to our detailing per panels, we'll start a new reinforcement that will run from this point up to this point, and do not forget our concrete cover of what, 25 millimeter. We'll trim this out, then we can return this to 100. Then we can take this what, reinforcement to this part. Okay, so after we've taken this reinforcement to this part, we can now calculate what, the total length of this returning top bar, and our total clear span here, we have it as 5.6 meters. So if we come to our calculator and we'll multiply 5600 by our 0.25, then we have a length of what, 1.4 meters. So in essence, this reinforcement will return into this slab as a top bar by 1400 millimeters. Okay, and we'll also match these properties. We'll also match this to represent what our top bar. And for this case, let's treat this separately. Let's treat this as what a separate reinforcement. So now we are done with the reinforcement that will be running on the vertical axis for these very panels, and let's come to the reinforcement that will be running at what the horizontal axis. Okay, so we'll also start from this part, and over here we'll have our reinforcement running from here to the end of this panel, and this can go in by what 25 millimeter, then this can return down by 100 millimeter up to this part. Then we have to dimension the clear spacing of this slab, and we'll have here to be 4638. okay, so if we multiply our 4638, or we can divide this by 4. Okay, let's divide this by 4. We have what 1159.5, which is approximately 1160. So we can come over here, select this, then we'll extend this into the slab by 1160. All right, and do not forget to match the properties of this reinforcement with this. So we also have what our bottom and our returning top bar. Okay, so we'll do the same thing for this panel, and for the fact that we are detailing per panels, like I've always been repeating, it is assumed, or it is advisable to create another copy of this reinforcement up to this part, because you are detailing, your detailing style is per panel. So we represent this same type of reinforcement over at this very panel. So remember, what we are trying to do is just indicating that this reinforcement will be running. We'll have one here, and we'll have another one at somewhere here. Okay, we can have another one here. So this reinforcement will be running all over this panel, just like this. Okay, like this. And if you observe, the same length of slabs we have here is the same length of slabs we have here. So in essence, we can still repeat this same reinforcement, okay, at what this other part of the slab. But since we are detailing per panels, for the fact that we are detailing per panels, I will prefer we'll copy the same reinforcement onto this other panel. Okay, so we have the same return length, and we have what an unrestrained end at this other part. Okay, so now we are done with this other section, and let's move on to the left hand side. So same thing we did for here. This reinforcement is also what we be used for this other part. Okay, because they also have the same width, and what they should also have what the same return length of the top bar. All right, now let's deal with the horizontal axis of this very panel. So if we run our reinforcement from this beam to this beam, and we observe our end conditions, by the right hand side we have what, and we have a slab at this very point. Then coming to the left hand side, we also have what, a slab at this very part. But in this case, we do not have what, a beam restraining what, our end slabs. So this will lead us to detailing this other panel as regards to the principle of a cantilevered slab. So when you are detailing the cantilevered slab like this, you are expected to what, draw your reinforcement to the end of your cantilever, which is 25 millimeter from the concrete cover, terminate here, and let's go up to 100 as well. Then for this return, you are not expected to stop at 25% of the width of this very span. Okay, you are not expected to stop at what, 25% of the width of your cantilevered span. You are expected to return this reinforcement up to this support here, which is what, our tie back. You have to return this reinforcement to what, the tie back. Then from the tie back, you have to go back into this slab by what? 25%. So keep in mind that if we have something like this, we'll come here and we'll return, we'll stop here, then we'll return into the slab by what? 25%. But if we are to handle a case of a cantilever slab, when we get to the edge of our slab, which is at the edge of our concrete cover, and we have what? Our bent up length, we are not expected to stay at what? 25% of the width of this slab. We are expected to return this reinforcement to our tie back, which is this. Then from our tie back, we are to extend another length of what? 25%, or 50 multiplied by what? The diameter of your reinforcement, whichever is greater. So what we'll do is we'll dimension this, and this length we have what? 3.9 meters. So let's erase this, then we can multiply 3,900, or we can divide 3,900 by 4. Then we have a length of what? 975, which is greater than our 50D of what? 600 millimeter. So this reinforcement should return as a top bar into this part as what? Our 975. Okay, so now we can match the properties of this to this, and do not forget that we can as well, merge this reinforcement together. Okay, so this will be something like this. Okay, so now we have what? Our reinforcements, and this is how to deal with your cantilevered edges. And as you know, this same cantilevered arrangement, it's also what we have what on this other part, and also what we have on this other part, because they have the same width and they have the same width of the cantilever. So we can copy this reinforcement from here up towards this part, and we can also copy this reinforcement from there to this part. Okay, then now let's come back to what? This vertical reinforcement. Remember, we are detailing per panels, and this rules applies to detailing per panels. So we'll come back here and we'll start our reinforcement at the end of this beam. So this, we have a slab at both the walls, top and at the bottom, so we do not need any calculations. This can stop at the end of our beams. And the next is from here to somewhere here. Okay, you can offset your 25 millimeter, then we'll return this by 100 bent up length to this part, and we can dimension this and compare it to our 600 millimeters. So here we have 2950. So we'll come to this part and we'll multiply 2950 times 0.25. So now we have 737.5, which is approximately 740. Okay, so we can come here, drag this up to 740 millimeter. Then we can choose to match this as what? As our top bar. Okay, so in less than no time, we've been able to represent how this reinforcement will run on site, and this is what the artisans will look at and know how they have to position our slabs. So let's come back to this part, and we have somewhat unfinished business here. Okay, and do not forget, this should be detailed as a one-way slab. Okay, so now we've provided the reinforcement that will run at the shorter axis, so we need to provide our distribution reinforcements. Okay, and we'll also provide this distribution reinforcements to be same as this. So we'll copy this, and this will also run within this panel. Do not forget that we are detailing per panels. Okay, and same as this part of the cantilever, and same as this part of what the cantilever. All right. Okay, so now we are done with what our bottom reinforcement. We are done with our bottom reinforcement, and we've also been able to implement what some top reinforcement. Although we still have some top reinforcement that will be running at these sections that will be having what our hugging moment, but we'll get to that. And let's start a bit of what our call out. So when we call out this bottom reinforcement, we can in turn be implementing what our top reinforcements. Okay, so you permit me to move this grid line up. Let me move this up a little bit to somewhere here. Then I will drop a line here, and I'll extend to the grid line to these lines. Okay, then let me also draw a line here. Then I'll move these annotations to somewhere here, and I can extend my grid lines here. Okay. All right, so let's begin the call out of what our reinforcements. So this is the part where we get to decide which reinforcement will be our B1, which reinforcement will be our B2. So we'll come here and copy a sample of our call outs, right? And let's put this here. So we'll start with the very first panel, and it is advisable to keep your B1, or by standard your B1 should always be the reinforcement that is running at the shorter span. Okay, that is the reinforcement that has what the shorter length. So as you can observe this slab, we have this first part as 3 meters, and we have what this second part as what 4638. So by indication, this reinforcement running parallel to this shorter span should be what our bottom reinforcement at the level 1, while the main bar running perpendicular to this other length of 4638 should be the reinforcement at what the layer 2, due to what their length. Okay, so this will be our what bottom reinforcement at layer 1, and this will be what the bottom reinforcement what at the layer 2. So we can go ahead and erase this, and let's create another copy of this to somewhere here. Okay, then we can start with this very reinforcement on this axis. Okay, so we'll start with this. Then this reinforcement it will be placed, or it will run. This reinforcement will run like this. We'll have one here because we are making use of our provided spacing, okay, which is at 200 mm spacing. Okay, so this reinforcement will run here, and we'll have another one here after another 200 spacing, and we'll have another one here after another 200 spacing, and we'll have another one here after another 200 spacings. So what we are just trying to do is to call out these numbers of reinforcement that will be required to construct this slab per panels. So let's go over and erase this. Then we can use these arrows to represent where this reinforcement will run. Okay, and it will run from the end of this beam up towards the end of what this other beam. So we'll move this arrow downward from here up to what somewhere around here. Okay, then this one will also move from here to somewhere around here. Then we'll get to extend this call out line to the end of this, and this circle we have to touch the reinforcement we are calling out. Okay, So we are calling out this very reinforcement that will run between this beam and this beam. And like we said, our total length here is what? 3000 millimeters, which is 3 meters. And if we are detailing by this action of 200 millimeter center to center spacing, then we have to divide this 3000 millimeter by what? Our spacing. So what we'll do is we'll divide here by 200, and we'll have a total number of what? 15 reinforcements. Okay, so this means 15 numbers of reinforcement is what will be needed to run between these two beams. But in cases where you have a round figure like 15, it is advisable you add one number towards that total number of what? Reinforcements. So this will take us from 15 to what? 16 numbers of what? Reinforcements. So we'll erase this, and we can move this colors to this part. Then we can edit this to the total number of reinforcements, which is what? 16. Okay, so if you get a round figure, add one number. But if you get let's say you were having about 15.5, you can just approximate to the nearest whole number. Okay, so we have what? 16 over here. Then we can now come to our call out, and on our call out, the first number here, which is this 24, is the number of reinforcement required for that panel. Why this is what? The diameter of what? Our reinforcement. This 13 over here is what? Our bar mark. Why this other one here is what? Our spacings of reinforcement. Then this is the arrangement of our reinforcement, which is what? Center to center, or it can be what? End to end. Okay, why this last annotation here is actually talking about the layer of what? Your reinforcement. Is it at the bottom layer, or it is at what? The bottom top layer. So for the first one here, we have 16, so this will be 16 numbers of what? Y12. Then our bar mark, since this is the first reinforcement we are calling out, let's take this as our bar mark number 01. But there are other rules that guides your bar mark, and we'll also get to see them in this series of lectures. Okay, so this reinforcement that will be having 16 numbers of Y12 will be running at 200 millimeter spacing along this span, and this is our second layer of what? Reinforcement at the bottom zone. Okay, so this will now come to what? Either our B2, or we can call it what? Our B top, which is what? Our bottom top. Okay, so let me leave this as B2, and this is how you can what? Call out your reinforcement. Okay, so like we earlier said, we can choose to run this line from this point up to this point. Okay, because the same reinforcement we have over here is the same reinforcement that will be implemented here, running from what? This panel to this panel. But what we can do in that case is to what? Copy these other annotations from here. Then we'll calculate the total number of reinforcement required to run in between these other two beams. Then we add it to the reinforcement required to run in between these other two beams. Then that will now give us what? Our total number of reinforcements. Okay, so that will give us our total number of reinforcements over here. Then also our bar mark will remain 0, 1, because firstly they have what? The same bent up length, and they also have what? The same length of top reinforcement that will return back into what? Our slabs. But let's stick to what? Our detailing of panel by panel. Okay, so we'll trim this out, and what? We erase this. So we can copy this reinforcement, and this, we can copy this call out rather from here. to somewhere here. Okay, then we can move this from here up to this point. Let's move our top bar here. Okay, and let's shift this a little bit so it does not interfere. We can move this to somewhere here. Okay, then we'll extend this line from this part towards this part. Okay, then we can copy this from here to here, and we can mirror to this part. All right, so this call out is actually representing this other reinforcement running here. Okay, so this is running at a length of what, 5.6 meters. So if we divide what our 5.6 meters 5600 divide by our 200 millimeter spacing, then now we have 28. And do not forget our rule, we'll add 1 to this, and this will take us towards a total number of 29 reinforcements. Okay, so we'll edit this to 29 numbers of reinforcements that will be running within this span, and this will also be changed towards 29 numbers of Y12. We can leave this at 01. So we can leave this at 01 since we have what, same type of reinforcement, but let's call this out separately as well, and let's call this what, 02. Okay, so this is how we can detail, or we can call out our reinforcement. And do not forget our layer. Okay, so for this case we have this reinforcement running at what, the shorter span. As you can see, this reinforcement is what will be running on this direction, which is this direction. Okay, sorry, so this is now like the shorter span in between this and this. So in this case, this will no longer be what, our B2. This has to return to what, our B1. All right, so this is how you can call out this reinforcement separately. So we are done with the reinforcement running on the vertical axis, and let's go to the reinforcement running on what, the horizontal axis. Okay, so we'll erase this, and let's move this here. Then we can rotate, and let's take our call outs here, and let's drop this from this point. Okay, so we'll have to detail this other reinforcements. So for this, we'll move all of this from here to somewhere here, and this call out will stop about 30 millimeters from the face of our beam. So we'll drop this here, and we'll also get towards drop this at the end of our beams. Okay, then we can extend this call out line from here up to this point, and this is the reinforcement we intend to call out. Okay, so let's dimension this length and get the numbers of reinforcement required to run along the span of this beam. So if we dimension this, we have a length of what, 4638, and if we divide our 4638 by 200 millimeter spacing, we have 23.19. okay, and this we can approximate to a total number of 24, a total numbers of 24. So we'll edit this reinforcement to what 24. Then we'll come to this call out. Okay, so on this call out we'll have what 24 numbers of what y12, and our bar mark will be what 03, since is the third reinforcement we are calling out, and this will be running at 200 millimeter spacing center to center. Then let's look at the layer of the reinforcement. Since this will be running perpendicular to the short side, this will act as what our B1 or what our BB. So we'll come here and we'll change this to B1. Okay, and the same thing for this. Let's copy this with this call out, and that will be same thing for this other reinforcement over here, this very reinforcement. So it will also run within this span, and the numbers that will be required is 24. But the only difference between this is when we get to this panel, due to the fact that it is the longer reinforcement, this will turn to our B2. Okay, so we can leave the total numbers of reinforcement required, and we can move this from here up towards this point. Okay, so this is how you get to call out your reinforcement per panels. So now we've been able to see how we can deal with these bottom bars diligently. Let's look at how we can start introducing our top bars into this set of panels. So to introduce our top reinforcement, so let's take an illustration of this section, and let's say we have our reinforcement running from here up to this part at the bottom zone, then it comes up to this part and returns into our slab by 25% of this span. So now we have what our reinforcement as the first layer, and we also need to provide what a reinforcement at what the second layer. Okay, so this is for the bottom zone. So we'll be having something like this at the spaces of what 200 millimeter. We have what a rigid connection. We have those reinforcements at the layer 1 and the layer 2 connected together by what our binding wire. Okay, so this will actually create what a rigid base. But for our top reinforcements, if we just return this other part at the top zone, this reinforcement will be left flapping. Okay, this reinforcement will be left flapping just like this. Now we need to provide what a top bar that will help to hold this reinforcement in place and also get to distribute the moment of this reinforcement all across what the 25% of this return. Okay, so there will be need to what provide what another layer of what top reinforcements. It all depends on what the arrangement around that area. With that understanding as well, when we provide a top bar at this other zone, right, at this zone where we have the maximum negative moment for our slab, there will also be need to provide another layer of reinforcement that will hold this top reinforcement in place. Okay, we'll also have what another layer of what reinforcements to hold this what top reinforcement in place. So this will now need us to creating what our top bar layer 1 and what our top bar layer 2. So let's come over here and begin the introduction of what our top reinforcement. So our top reinforcement will be, we will start with this acting on the beam areas. Do not forget that we already have what one set of the top reinforcement here, which is connected to the bottom reinforcement at this part. Okay, so let's start with this, and for this we should be having this from this to this panel. Then we also have to go here by 25% and also go to this other panel by what another 25%. Okay, So we'll come here and we'll dimension this. This is 3 meters, and which gave us what, 750 millimeter as what, the 25% of 3 meters. So let's try that. We have what, 3000 divided by 4, so we have what, 750. So for this part we'll be having a length of what, 750 as the top bar layer 1. Then this part will be having what, a length of, that should be 1.4. okay, so this other part will also have what, a length of 1400, because the width of this is 5.6 meters, and when we multiply 5600 by 1 by 0.25, we have what, 1400 millimeter. okay, let's move this here a little bit. Then we can match these properties to indicate that this is what, our top reinforcement. okay, now this is allowed to run on this very beam from this point to this point. okay, so this top reinforcement is only functional within this span. okay, so on getting to this part, we have what, a different grid, or a different structural arrangement, a different beam structural arrangement. So for this case, we'll have what, our top bar here, which will also go 750, because here we have what, 3 meter as our clear span. Then for this part we have to dimension this, and we have what, 2425. okay, so 25% of 0.25 multiplied by 2425, we should have what, 606, which is almost same as what, our 50D, but we'll use a length of 610 millimeter. And if you are detailing with softwares like CAD RC, it is advisable you always stick to what, your accurate dimensions, because this is what we use in the calculation of what, your general quantity, the quantity of your reinforcement required. Each and every of these extended lengths are very, very important in estimating what, the quantity or the length of your reinforcement that is required. So we'll extend this at 610 from this point. okay, then we can also match these properties to indicate this is what, our top bar. Then the next is this as well. Then we can go here by what, 610, and in this part we have a length of what, 2950. So if we multiply 2950 by 0.25, we have what, 740. okay, so we can extend this by 740 millimeter. all right, so we can now match this as what, our top bar. So this will run from this part up to what, this part. okay, so we are done with the top bar at the support zone for each of these panels. Now let's come to the horizontal, let's come to the vertical beams. So for this part we have what, for this part we have a length of 4638, and for this part we have a length of what, 3900. okay, so if we multiply, it will multiply, or if we divide 3900 by 4, we have a length of 975. okay, so this will come into this part of the slab by, let's see, 975. So we can choose to draw this anywhere, but let's draw here 975. okay, then we can extend this here, and we can calculate this part as well. 4638 by 4638 by 4, and this will give us 1160. Okay, so we can take this to 1160 and we hit what? Enter. So we can match these properties to indicate that this is what our top reinforcement. Okay, so now we have what? The top reinforcement at the first layers of our support zone. So now we are done with what? The introduction of what? Our top bar at the layer 1, and let's introduce what? Our top distribution bars. So to introduce this top distribution bar, you have to be reminded that these bars will only run at the extent of what? The reinforcement, the top reinforcement at the first layer. So that's to say, our top distribution bar is only allowed to run at the extent of our top bar at the layer 1. So any top distribution bar we are providing can only run from somewhere around this area for this very top bar. Okay, why for this other part it is only allowed to run with this length, with accordance to this length. Okay, so we'll start with this very panel, and we'll have what? Our top bar at the layer 2. It will run from somewhere here. Okay, and the reason why it is running from somewhere within this slab is because we already have what? Top bar at what? Layer 1. You already have this other top bar at layer 1 running from here up to, let's create another one here, running from here up to what? This part. Okay, so we cannot extend this top reinforcement at the layer 2 to somewhere here, because this will almost make us have at about 4 layers of what? Reinforcements. Okay, so when you are detailing with softwares like CAD ROC, this is very useful because it will limit you to the adequate length. So when it is calculating your total quantity required for the reinforcement, it can take recognition of each of their start and their stop lengths. So let's draw this from this end, and it will also end at what? This other part. Okay, so you can also stop here. So this top bar at the layer 2 is only allowed to run from here to here, and also allowed to run from what? Here to what? Here. Okay, so we'll match this together and know that this is a top bar. So this is one, and we also work with the top bar for these other panels. Okay, so this will cover this part and this other part, while the next top bar will cover from here up to what? This point. Okay, we can as well use the same reinforcement for this other part, since they have the same length, they have the same width. Then we can call out each of the sections separately, but do not forget we are detailing per panels, hence we have to stick with the rules of detailing per panels. Okay, so if you see someone else, or if you see another detailing materials that you have just this one called out, and it runs from here to this point, and it also runs here and also runs here, which ideally on site, that is how it will be implemented. Okay, it is not wrong, but we are detailing per panel, so we have to stick with detailing per panel. All right, so let's copy back these reinforcements from here to somewhere here, and we'll also make another copy to somewhere here. Okay, so these are the top bars that we hold these other top bars at the layer 1. Okay, so we are done with this very panel on the horizontal, on the vertical axis, and let's also move to the vertical axis of this other panel. So we'll have reinforcements coming from here up to here, and we can match this as our top bar. So this will run across this top bar layer 1, and we'll also touch this and this as well. Then it will also touch this and this as well, and it will also touch this. Okay, so as you can see, we are already having what a more complex detailing. We are having a more complex arrangement. Let's take out these dimensions. Okay, then let's deal with the top bar on the horizontal axis. So our layer 2 top bar will also get to run from this 25% from here up to this part, and let's match this to this part, so it will hold this return. Then if we copy this as well, it will also hold this other top bar at layer 1. Okay, it will hold this as well. It will run here and also run here. Then we can copy this up towards this zone. Okay, so by the reason of this reinforcement, which is at the second layer of the top bars, we can apply the same principle to these other panels. Okay, but not to make this too filled up, not to make these panels too filled up, let's start calling out these reinforcements at the top zone. Okay, so we can cover much with the little time we have. So we'll create a copy of this. Okay, and let's start by calling out what this top reinforcements. So we'll create a copy of this, and this as well. Okay, so we can copy this from here to somewhere like this part. All right, then we are calling out this very reinforcement, so let's move this down a little bit. Let's move it here to somewhere here. Then we can move this from here to this. Then we said this reinforcement will be, let's move this a little bit to have what a clear spacing. Okay, so let's move this reinforcement here from here to somewhere here. Okay, or somewhere around this part, and we can call out this to somewhere here. All right, so we'll move this other call out arrow from here to here to indicate this reinforcement is stopping at this point. All right, then to get our total numbers, we just have to dimension this, since we are also using 200. So this is 750 and 750 by 750 millimeter by 4. Then we have what, sorry, 750 by 200, we have what, 3.75. so that leaves us at what, 4 numbers of reinforcement. Okay, so we can trim the extent of this line to this part. We can trim this extent, and we can edit this to what, our 4 numbers worth of reinforcement, which is running from here to here. Okay, so let's come out and edit this call out. So we'll edit this to what, 4 numbers of Y12, and the last bar mark we had was 03. So this will now be 04, also running at 200 millimeter center to center spacing, but in this case we have it as what, our top layer 2, or our top. Okay, so we'll edit this place from B2 towards our T2. Okay, so these are the top reinforcement at layer 2. Now if we had called out this reinforcement separately, like we said earlier, if we have called out this reinforcement separately, then we can now detail this other top bar up to this part, and this will now serve as what, our T1. Okay, this other part will now serve our T1, but for us not to have so many drawings or so many lines on this drawing, like we earlier said, and since when they are constructing on site, they just have to return this reinforcement to this other panel, we don't necessarily need to differentiate them. By this indication, they will get to understand that when they return this reinforcement at the top zone, this will be used to redistribute these bars. It will be used to redistribute this load across this top zone from here to this point. Okay, so we'll move on to the next top bar, and let's create a copy of this to somewhere here. Okay, and let's move all of this. Let's move all of this. Then we can call out this other reinforcements here. Let's call this out. Okay, we can extend this line to this part, then can make adjustments to the position of this bottom bar. Let's take this bottom bar from here up to this part. Okay, so we'll have this at the body of this reinforcement, and this will be running from here to the end of what this top bar at what the layer 1. Okay, so we can move this from here to here to indicate it is stopping here, and let's also make further adjustments to the position of this reinforcement. Okay, then we can move this here. So let's dimension this, and we have what's 1.4. so if we divide 1.4 by this, we'll be having a total of what, 7, and that leads us to approximately 8 numbers what of top bar. So this changes to what, 8 numbers of what, our Y12. The bar mark, this will be 0.5, running at 200 millimeter center to center spacing, and this is also what our top at what, the layer 2. Okay, so this is how we can detail this. Then for this one in the middle of this part, we can as well copy this. Let's copy this here. Okay, then we can move all of this to somewhere here. Let's move it somewhere here, and let's move out this other reinforcement to somewhere along this path, so we'll have a clearer spacing. Okay, then we can extend our call out line from here to here, and this will be anchoring this very reinforcement. And this is our total length. Okay, so if we dimension this length, we should also be having about 4 numbers of, let's dimension this. So this is 750, so 4 numbers just like we have over here. Then for these other parts, okay, it will have to extend to cover, because this is running on this top reinforcement at what, the layer 1. So this will also have to cover up to this part. Okay, so what we'll do is we can mirror this from here to here. Then we can extend the limit of this to this part, and we can extend this line from here to here. Then since we have 4 here, we'll create another copy of the color text, and we have this to be same numbers as this, which is 8. Okay, so this will be 8 numbers. This will be 8 numbers of reinforcement, and this will be 4 numbers of reinforcement. Okay, so 8 plus 4, this will give us 12. So we can now come here and change this to what, 12 numbers of Y12, and the bar mark should be 0.6. at running at 200 millimeter spacing center to center, and it is also what a top bar at what the layer 2. All right, so that is how you get to call out your reinforcement. But so far we've been only calling out the top reinforcement at the layer 2. So now let's call out some top reinforcement at what the layer 1, and we'll have to come to this other reinforcement that is running across these beams. Okay, so what we'll do is we'll create, or let's start with this one. So we'll create this, and we'll copy this, copy the donuts, copy the arrows, and we can copy from here to somewhere here. Okay, then we can move this because it will run from here to here, so we can move this from this point to this point, and we can also move this from this point to what, this point. Okay, so we'll trim this call out line to this part, then we can now move this arrow from here onto what, this. Okay, so this top bar at the layer 1 is running between this beam. All right, so we have to get this length, which is 39, and divide it by the spacing. Okay, so if we also do that, we'll have what, 3900 divided by 4, and now we have what, 3900 divided by 200, and now we have what, 20 numbers of what, reinforcements. Okay, we have 20 numbers of reinforcements. All right, so this part will be changed to 20 Y12, and this will turn to 07, running at 200 millimeter center to center, and this reinforcement is at what, our top bar layer 1. So this changes to T1, or what, our T bottom. Okay, so this is how you can represent this. Okay, so this is the general idea behind all slab detailing. Okay, this is the general idea behind our slab detailing. So we'll go ahead and what, apply these very principles to every other reinforcement that has been called out or has been drawn on what, this very slab. Okay, so we'll go ahead and start making modifications to the call out of each and every of these reinforcements. So if you follow the principles we've been dishing out for your reinforcements and also your call outs, you will arrive at a slab detailing that looks just like this. And let's get to look at this slab detailing. So for this very panel here, we have the bottom bar. This is the first bottom bar, and this is the second bottom bar, because this is what, a two-way slab. Okay, and this is running on the shorter span. The length of this reinforcement, this is the shorter reinforcement. So this is our B1. Okay, that's for this, and the total number required to run between this beam and this beam is actually what, 24 numbers. So this is what called out as 24 numbers of Y12, and the bar number is 15, running at 200 millimeter center to center spacing, and it is the reinforcement at the bottom bar layer 1. So same applies to this becomes what, our bottom bar layer 2. All right, so we go ahead for the next panel as well, and the same principles applies to all of this. And for this side, we say we'll separate this bottom bar from the returning top bar. So hence we have a different detail for our top bar, which is the top bar at the layer 1. All right, and this will now get to distribute the moment of this reinforcement over this area, and 8 numbers of this reinforcement will be required to distribute this moment. So we'll move on to the next, and we should have this running on this shorter span as what, our B1, while this will be what, our B2. So this is how you can detail your slabs. This is how you can detail your slabs effectively. If you have other topics you would like us to treat, you can leave it in the comment section. So if you found this video helpful at any point, do not forget to like it, subscribe, and turn on the notification bell of our channel so you get notified anytime we post new videos on our channel, because we really have a lot coming your way. So see you in the next class where we'll be detailed per length of your reinforcements.